Good afternoon, everybody. Good afternoon, everybody. Am I audible to all? Good afternoon, everybody. Let's start with the class. कोई है क्लास में वैसे? Good afternoon, everybody. Am I audible to all? Is anybody there in the class? This is the English batch. The whole lecture would go in English. Anywhere by mistake, if I start speaking, please stop me. Or I would be speaking English only. Don't worry. In case if I start speaking, please stop me there and there. Anyways, let's start with the class. Let us start with the class. Let's start with the class. This is steel structures. Good evening, everybody. Today we will be starting with a new topic, that is steel structure. In that we will be covering our first topic, that is general design structuration. Before starting with the subject, let's see a brief introduction. This class I would be mostly covering the introduction. We will introduce design of steel structure here. Then we will see various design philosophies. The design topic similar to RCC. Requested that first of all you cover RCC, then you take steel. First see RCC, then you take steel. That would give you a more better understanding to this steel. Okay. Then we will see all the design philosophy on the basis of which the steel structures are designed. Philosophy. And lastly, I would be talking about all the various kind of load. Let's see the discussion in detail today. First, let me introduce the topic. These are the topics that I would be covering. We will be seeing general design consideration, plastic and bolted connection, welded connection, tension member, compression member, beam. See, these topics are not there for gate. These topics are only for ESE. The last three topics I won't be covering. These are only for ESE. This whole class is gate oriented. So if you are preparing for ESE, then these three topics also you need to prepare. But here I won't be covering it in much detail. So I will share the notes here only for ESE. So in gate, questions are generally not asked from these topics. These plate girder, gantry girder and industrial building, it is mostly important for ESE. Rest all the topics I would be covering. Okay. Good evening, Mr. Abdul Faseed. So today we would be studying design of steel, that only I was speaking to you. So let's begin our lecture again. What I was saying, that in gate, what are the important topics that you need? First of all, see the weightage in gate. If we talk about the weightage in gate, the weightage of steel is very less. For gate, the weightage is around 2 to 4 marks only. And in some years, there was not a single question asked from design of steel. In the last year, if you will see the first set of gate, there was no question on steel structure. The questions that are asked is okay, Abdul, from the next year we would try to have ESE classes also in English. Currently we only have this gate batch in English, and that was also introduced based on the demand of students only. But from next year we would try to have ESE classes in English as well, okay, like we have in English. Okay, anyways, what I was saying is, if the weightage of this topic in gate is very less, and mostly the questions are analytical point of view. So I won't be covering the design topics or the design questions here, because the design questions are not asked in gate. Okay, so here we would be covering the design of steel structures as per the gate standard. So in the gate, only analytical questions are asked, design questions are not asked. So our focus also would only to cover the analytical questions only. We won't be covering the design questions. Okay, those would be covered in the ESE batch separately, where it is launched. So, if you ask me what are the important topics for GATE, see, GATE is nearby only, we are all focusing on GATE 25 and we are almost on the last leg of our preparation. So, I won't advise you to read the whole syllabus, it is not required that much. There are few topics that are very scoring and from these topics only mostly the questions are asked. What are the important topics from which the questions are generally asked in your exam? First one is plastic analysis, the questions are asked from here, then bolted connection, welded connection and lastly compression member. If you cover all these topics, mostly the whole paper would be covered. Mostly the questions are asked from these topics only, that is plastic and compression. Today I would be discussing the general design concept. After completing this, we have a next class as well that we will be covering, will start the plastic analysis. Okay. You might have read design of steel structures in our college also. What are the important books that you can follow? One book is Design of Steel Structures, Limit State Method by N. Subramaniam. This is the Bible here. So, I won't advise you to procure the books. Want any book for reference, then these two books you can procure. Both books are very good. First one is Design of Steel Structure Limits by N. Subramaniam. Second one is Limit State Design of Steel by S. K. Dubey. These two books are very good books that you can purchase for your references. Otherwise, these notes that I am sharing with are more than enough for cracking GATE. Okay. Let us begin with our discussion with design of steel structure. Let us start with our first topic, that is general design. Am I clear till here? Uday Shankar and Mr. Abdul, how is your preparation going on? Uday Shankar. Okay, let us begin. Let us begin. General design consideration is similar to that of RCC. You already understand what are steel structures. Okay. So, what are steel structures? What are, you might have seen a steel structure. Steel structures are structured like this. These are the basic kind of steel structures that you see in civil engineering. You can have tapered portal frames that are used as industrial building. Then you can have braced portal frames like this. You can construct multi-story buildings out of the steel. So, you can have this rigid frame structure or a geodesic dome. These are the various kind of steel structures that you can see that are being used in civil engineering. This transmission tower, guide tower, etc. These are all steel. Then you can have the steel water tanks, you can have industrial silos. These are all basic kind of steel structures that are being used. See, the steel structure is very different from the RCC. First of all, you need to understand the design of RCC is very different and the design of steel are very different. In case of RCC structure, you have monolithic casting, but in case of steel, you do not cast it at site. Join various steel members that are available at site and prepare the whole structure. So, with the member design, you have to design the connections also. The connection design is also very, very important here, because if the connection fails prior to the failure of member, that will lead to a catastrophic failure here. Okay. So, the member design should be accompanied by the connection design as well. So, the very basic requirement of the design of steel structure is member design as well as the connection. Okay. And next of all, the basic objective of the design is what? Whatever design you are doing, you have to ensure first of all safety. Safety should be there during the design life of the structure, and it should be serviceable as well. That is, it should perform satisfactorily during its design life. And last but not the least, economy. Your design should be, but safety is very, safety and satisfactory performance is very important. Then the next important stage will be of what? The next important stage is of phenomenon. Okay, so the objective of design should be the achievement of an acceptable probability that the structure will perform satisfactorily for the intended purpose during its design. With appropriate degree of safety, the structure should all the loads and deformation and its design life, and also have adequate resistance to any accidental load as fire. This is the basic philosophy that we always while designing any of the steel structure. Now, there are certain advantages as well as disadvantages of steel as compared to our RCC. First advantages, let us see what are the advantages of steel structure as a structural material, or advantages of steel as a structural material. First, it's have high strength per unit weight. It's ductile, it's not brittle, it is ductile in nature. This you all understand, I guess. These terms, it's an advanced topic. If you have not read strength of material, so I would request you not to see, because this design of steel structure is an advanced topic. First, you have to clear the strength of material and structural analysis, then only you will be able to understand design of steel. Have you read through strength of material as well as the design of structural analysis? Tell me fast, please. Have you studied these two topics or not? Tell me fast. Okay, strength of material also you have seen as well as structural analysis. Very good. Things you understand. These are the basic advantages of. Let us move forward. Okay, whenever you have any doubt, you can stop me there. First, we will understand the whole topic, then you can take the notes at home, or if you find time in the class, you can take notes here as well. Only two of you are there, so you can proceed at our pace. Okay. So steel have high strength per unit weight, ductility is very high, steel is very tough, is very lightweight as compared to the RCC structure. Erection is very fast because now you don't have to wait for 28 days for development of strength. Then there is a high scrap value. But the RCC structure have very negligible scrap value, but here the scrap value will be very large. And last but not the least, that steel is recyclable. But there are many disadvantages also of using the steel. First major disadvantage is susceptible to rusting and requires fireproof treatment. It is not fire resistant. If the temperature becomes very high, the steel might melt and thereby lose all its strength. That might lead to a brittle failure. Therefore, steel requires a basic fireproof also. It's an excellent heat conductor. It's also a major problem because the heat can be easily introduced throughout the steel, thereby leading to decrease in the strength. As you increase the temperature, the strength of the steel will decrease. And lastly, the fatigue. Steel undergoes fatigue. Fatigue, you understand? It is rapid reversal of stresses. If occurs in case of steel structures, it might undergo rapid failure or brittle failure. Fatigue means that, what do you understand by fatigue? Reversal of stresses, known as fatigue. Means if there is a steel structure, it is in tension sometimes and it is in compression sometimes due to dynamic loads due to wind or earthquake. This might lead to fatigue failure in our. Due to fatigue, the steel loses its strength. Let's proceed further. First, let's talk about the rolled section. You understand what is a rolled section? Rolled sections are sections that are fabricated in factory. So, as a designer, we first of all prefer the rolled sections. Sections are of two types. One is the rolled section, one is the built up section. Rolled section are those sections that are manufactured in industry. Built up sections are those sections which are built at site, as the name built up section. Rolled sections are obviously better, and the erection of structure with the help of rolled section be very fast. Built up sections are used only when the members are very heavy and the sizes are not available in rolled section or built up section. You are understand now what is a rolled section. So rolling is a process actually through which these sections are manufactured. You understand rolling of metals? Have you ever had a sugar cane juice? So how the sugar cane juice is extracted? With the help of two rollers. There is two rollers between which a sugar cane is passed. When the sugar cane is passed through the rollers, the sugar cane gets crushed and the juice gets extracted out of it. Similar thing happen with the metals. So between two rollers, the metals are passed. This process is rolling. Due to this rolling, what will happen? All the fibers of the metal will bind in one, thereby increase of the metal and make it more uniform. Okay, so rolling can be hot rolling as cold rolling. There are two kinds of rolling: hot rolling, cold rolling. All the kinds of rolled sections are given in a handbook, that is IS handbook number 1. This IS handbook number 1 is available with the designer as well as with the industrialist. So just you have to call the manufacturer of the seal section and you just have to mention a code. You want this section. They will refer the IS handbook and they will make the section for you and they deliver it to your site. Okay, there should be a common language between a designer as well as a manufacturer. That language is actually IS handbook number 1, which all the sections are mentioned and their basic properties are mentioned, which will help the designer to design those sections and help the manufacturer produce a uniform section that are required by the design. We can have various type of rolled section. Rolled beam can be used as column also. This is I section. You can have rolled channel section like anal section, you might have seen it. This is the cross section I am showing you. Then you can have an angle section, you can have T section. Then you can have square hollow section, rectangular hollow section like this. Then you can have circular hollow section, EHS. Then you can have hollow solid tubes also, that is square tubes as well as the circular hollow sections. Okay, these are also bars. Hollow sections can be tubes or you can have bars as well. You can have tubes also, hollow tubes or the solid tube. Okay, then you can have flats here, you can have plates here. Plates and flats are one and the same, only difference is width. If width of the member is less than 400 mm, it is flats. If the width is greater than 900 mm, it is known as. Okay, these are the various types of rolled sections that we generally use. Got my point? Let's proceed further again. Not that important. Now we have compound section, that is built up section. This is a compound section made with the help of a flat or a plate, and the T section. Again, one of the compound section uses T and the flat. Then it is a section, T section, having wide cover plate on the flange. This is known as flange of the T beam. I guess these all terms you understand. Flange and web you understand now? For the I section, this is the flange and this is the web. The web of the I section is the flange of the I section. I section can be made with the help of plates also. 3 plates I have joined and I got the I section. Plates are connected with the help of welding. So this is the welded plate girder. Okay. Then you can have an I section like this also, which the top flange is reinforced using the section. You can have a box section like this, the built up box section. You can use 2 angle section to make a T section like this. You can make an I section with the help of 2 channel sections also like this. These are the various types of possible built up sections that are used. Now let's come to the main part of the chapter, that is the design philosophy. Design of steel structure, of designing of steel and their connection, that the applied loads can be resisted. So, our main purpose of designing it, we have to ensure that all the loads are passed, or all the loads are passed successfully or transferred safely. There should not be any failure of steel member or any connection when the member is loaded. There are three types of design philosophy that we use in steel design. First one is elastic or working, I will discuss in detail. Plastic or ultimate load method, and lastly the limit state. So, basic difference between these three design philosophy, manner in which the safety is considered in the. Now, let us see all these three methods in detail. First of all, I will show you working plastic method, and then we will see the limit state method of it. Am I clear till here? It's okay now? Only basic things I have taught till now. Now, let us talk about the working stress method of design. Let us talk about the working stress method. What is done in the working stress? Shall I proceed further? Very good. Clear? Sudhay, it's clear till here? It's clear na? You are able to understand what I am saying. I am talking in English, and this is the only medium of instruction. So, I guess you all are very much comfortable with the English that I am speaking. Okay now? Face any doubt, you can just interrupt in between. Shall I proceed further? Shall I proceed? Uday Shankar, are you still there or left? Okay, let's proceed. So now let's talk about the working stress. I have to increase my volume. From my side, the volume is already very high, but if you will say, I will still try to increase. But from my side, the volume is almost high only. But then I will try once. Okay now. I will tell the student to do. Okay, I have not done anything. Is it okay? Okay now. For the same. I am proceeding further. From our side, the voice is almost okay, but I will tell the studio manager to increase it a bit. Let me tell the studio manager. Till then, you read through this working stress design. Hello, Pradyuman. चेक 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 थोड़ा और बढ़ना है, रेड तक पहुंचा दो इसको, और बढ़ती है आवाज ना, अभी कम आ रही है आवाज. गेन बढ़ा दे क्या थोड़ा, देखो अभी ना भी बोलता तो भी रेड तक आना चाहिए. वॉल्यूम मिक्सर में जाना. फुट में तो नहीं आ रहा अपना. ये कहाँ से गए? हाँ ये सही था शायद. ओके, ये कहाँ से खोला आपने? देखो ये बड़ा, अब हाँ अब बढ़ गया एकदम. हाँ यहाँ से चले, ठीक है. हाँ ठीक 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 ठीक, अब परफेक्ट है. ठीक है ठीक है, डन 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 डन. चलो थैंक यू. Now it's okay, Mr. Abdul. Now we have increased our sound to the maximum level that it can be. Now it's perfectly fine, I guess. Sound is okay. Sound is perfectly fine. Now the sound is maximum, I guess. If anybody is uncomfortable with the sound, do let me know. Now let's proceed further. Now first of all, let's see the working stress method of design. I guess the sound have become very high now. Okay, now it's, let me increase a bit less. Okay, now it's perfect. Now it's perfect now. Okay, badhiya. Let's see what I was talking. I was saying now let us see the working stress method of design. See, this is the elastic stress strain curve of the steel. You already know this is a stress strain curve of the steel, stress and strain. This you have seen in strength of material as well. This is the elastic zone, this is the yield stress, and this is our ultimate stress. You know what this zone is called? This is my plastic zone and this is my strain hardening zone, and here the necking will occur. Okay, fracture will occur. So in the working stress method of design, we always design this member elastically. Means it will be designed up in this elastic region only. We will never utilize this strength of the material. So WSD, that is working stress method of design. WSD means what? Working stress method of design. It is WSD, working stress method of design. is based on elastic theory. Structures are analyzed elastically for worst combination of working loads, that is service load. Here we always work about for working loads. You will take the worst combination of the working loads and you will ensure that the summation of all the working stresses is less than the permissible stress, and the members are proportioned such that the permissible or the allowable stresses are never exceeded. So, for safety you have to ensure one thing. What we have to ensure? That summation of the working stresses due to the worst combination of the working loads. So, summation of the working stresses should always be less than equal to the permissible stress. So, the basic design philosophy is this only. It should always be less than the permissible stress. See, this is my working stress design. This you almost followed in strength of material as well, because when you are following this design method, then you are ensuring that the material is under elastic limit only or the linearly elastic limit only, because the permissible stress is equal to yield stress divided by factor of safety. Now, obviously, this method of design is not good. Why? This method is not good because here you have not utilized the reserve strength of the material. See, even beyond yield strength, the material have not failed. Your steel still possesses this reserve strength due to the ductility of the material. So, while designing the steel structure through working stress design method, we have not utilized the reserve strength of the steel. So, obviously, the members that you will design out here will come out to be very heavier. So, the members would be very heavier and the design will come out to be uneconomical because we have not utilized the reserve strength of the steel. And moreover, the factor of safety that you are using here is based out of experience. There is no mathematical basis on computing this factor of safety. The permissible stresses are defined as a ratio of yield stress to factor of safety, and the factor of safety that you are using here is based on experience. See, in the steel we have two codes that you understand, IS 800 1984 and IS 800 2007. 2007 is the review year or the revision year of the code. So, the old code of the steel was largely based on the working stress method of design, but that is obsolete, because whenever you design the steel structure through working stress design, the design will come out to be very uneconomical. So, the commonly used factor of safety for different structural elements are as follows. This you do not have to remember, not required, because in your syllabus working stress design is not there. In GATE only limit state design method questions will be asked. So, do not worry, these factor of safety you do not have to remember, just I am showing what is the problem with the working stress method of design. So, there are certain limitations for designing by working stress design approach. In working stress design approach, linear elastic behavior is assumed. This leads to uneconomical design because the structure possesses considerable reserve strength which is left unutilized due to the ductility of the material. The assumption that the stresses can be kept within the permissible stresses is not realistic. See, you are assuming that your stresses will always be less than the permissible stresses, but this is not happening in reality. Your member can have certain residual stresses, or it can have certain stresses due to stress concentration. So, at some point of the structure, the stresses even under working loads might be greater than the permissible stresses. So, it is very difficult to ensure that our stresses is well within the permissible stresses even under working loads. So, if you are considering that under working loads your stresses will be within the permissible stresses, this assumption in itself is very absurd, because due to stress concentration or due to residual stresses, that is due to difference in temperature, because whenever a hot steel is cooled, the temperature, the cooling might not be uniform, that might lead to temperature stresses out there. Those are the residual stresses I am talking about. So, your steel can have any internal stresses due to residual stresses, or there can be a stress concentration as well. Due to these factors, your working working stresses might be greater than the permissible stresses, but these factors are not taken into account while designing the structure through working stress method of design. And moreover, it fails to discriminate the loads that act simultaneously but have different degree of uncertainty. So, all the loads are given the same uncertainty. Okay, you understand this, you have studied this in RCC as well, I guess. Like, there is lesser probability of the wind load to occur and there is more probability of the live load and dead load to occur. But while designing the structure through working stress design method, all the loads are given the same probability of occurrence, which will lead to an uneconomical design. These are all the limitations. Okay, let's proceed further. This question was not that important. This was all about the working stress method of design. Now, let's talk about the plastic method of design. It is also known as ultimate load method. Here we talk about ultimate collapse. See, this I will cover in plastic analysis as well. See, here the failure will occur by the formation of a plastic mechanism. Whenever this is a overhang or a propped cantilever, this is a propped cantilever, you understand? This is a propped cantilever. Whenever you apply a load on this propped cantilever, what will happen? There will be formation of plastic hinges at the fixed end and on under the point load. When these plastic hinges are formed, it will lead to the formation of a mechanism. You understand what is a mechanism? Have you read through mechanism in structural analysis? You understand what is a mechanism? Tell me fast, yes or no? You know now what is a mechanism? Do you know what is a mechanism? Tell me fast, please. Do you understand? Yeah, mechanism you understand. So, whenever there are three hinges in line, that is known as mechanism. It will lead to large deformations, thereby leading to failure of the structure. So, here whenever you apply load, what will happen? Due to large bending moments at fixed end and under the point load, there will be formation of plastic hinges. How these plastic hinges are formed, etc. We will cover it in plastic analysis in detail, don't worry. So, currently you just imagine that due to the application of load, what will happen? The structure will fail due to the formation of plastic hinges like this. When these two plastic hinges will form, you will have a collapse mechanism which will lead to the collapse of the structure. And we have to find out the collapse load. So, here we are talking about collapse. See, this is better as compared to the working stress design method, because here we have utilized the reserve strength of the material. But again, there are certain limitations of this plastic design method. First, let us see the philosophy in detail, then I will show you the limitations again. In the plastic method, the design criteria is the ultimate strength. This method of design is based on failure condition rather than the working load condition. And failure implies collapse or extremely large deformation due to the formation of these plastic hinges. When sufficient plastic hinges are formed in the structure at the maximum stressed location, a mechanism is formed, resulting in the collapse or the failure of the structure. In plastic method of design, service loads are multiplied by load factor and the cross sections are selected and designed on the basis of the collapse strength. Now, what is checked here? See, here the basic design philosophy is what? Your working load into the load factor, that is summation of working load into the load factor LF, LF is my load factor, should always be less than equal to the collapse load or the ultimate load. Ultimate load and collapse load is one and the same thing. So, here we talk about the loads like this. So, for safety you have to ensure that the working load into load factor. See, load factor is kind of factor of safety here. So, summation of working load into load factor should be less than equal to the ultimate load, and here while calculating the working load, you will take the worst combination of load. So, all loads and combination except dead load, IL means imposed load, wet load or earthquake load, will have a load factor of 1.7. If you have a combination of dead load, imposed load, wind load, then the load factor is 1.3. This is the load factors that were given in the old code, that is IS 800-1984. The new code is silent about these recommendations. So, in the new code these recommendations are not mentioned about plastic analysis. So, for plastic analysis we will still refer the old code only, and these are the load factors that are taken into design consideration. Got my point? So, what are the basic limitations here? So, first advantage, you understand this method uses the reserve strength of steel, which is left designed in working stress design method. Obviously, if you design the steel structures using the plastic method of design, the sections will be lighter as compared to the working stress design, because here or you will have smaller steel sections here for the same loading, because you are utilizing the reserve strength of material here, okay, and it will result in smaller steel section as compared to that in the working stress design method. This you understand why the steel sections will be smaller for the same load conditions, because here you are utilizing the reserve strength of steel. Got my point? Very simple to understand. Let us proceed further. There are certain limitations of the plastic method. Following are the limitations. It does not consider serviceability conditions such as deflection, vibration, fatigue, etc. See, here we are only talking about collapse. We never talk about the serviceability condition, that is, we never talk about the deflection under the working loads or vibrations or fatigue, etc. because we are only talking about the ultimate collapse, but it might happen that before undergoing the collapse your structure becomes non-serviceable, but we are not talking about it. So, the concept of load factor was introduced, but there was no safety factor introduced on the material, okay. In the load combination, all the loads act with same probability. All loads are considered to act simultaneously with the maximum value, maintaining the same load factor. Again, the uncertainty in the load combinations is not considered here, which will again lead to uneconomy, okay. This was all about the plastic design method. Now, let us talk about the limit state method of design in detail. Am I clear till here, my dear friends? Tell me fast, please. Okay till here? It is fine till here. Shall I proceed? Very easy concepts currently. Many of the concepts you might have seen in the RCC as well. See, the limit state method of design that I will discuss here is more or less similar to that in the case of RCC. Anywhere if you find any doubt, just ask me, because this limit state method of design is already covered in RCC. So, I am not going into great detail here, because unnecessarily we will be wasting our time. Okay, you might have heard of limit state method of design in RCC as well. Okay. So, limit state method of design. So, whatever limitations were there in the working stress design as well as the plastic method of design was all removed in the case of with limit state method of design. Here we work with partial safety factors, and these partial safety factors are statistically calculated using the reliability analysis part 1. This reliability analysis part 1 is a mathematical probabilistic model. I am not going into detail because it is not in your course, but yeah, the partial safety factors that we are using in the case of limit state method of design are having certain mathematical justification. They are not just adopted out of experience. So, it is backed with certain mathematical theories, and those theories are actually covered in reliability analysis part 1, but that is not in your course. So, I am not going into detail. So, here partial safety factor is used, and it takes into account any possible overloading as well as understand. So, here we will define a factored load as well as a factored strength. Factored load is equal to what? Here we use factored load like this. Factored load is equal to, this you might have seen in RCC as well. characteristic load divided by gamma f. Gamma f is a partial safety factor for loading. You remember this? And factored strength is what? Factored load is characteristic load divided by gamma f, whereas factored strength is characteristic strength. You understand what is the meaning of this characteristic here? What do you understand by this characteristic strength? Divided by gamma. Okay, this will be multiplied here, not divided. This will be multiplied here. Okay, I have to make some characteristic load into gamma f, and here characteristic strength will be divided. So, with the help of partial safety factor of loading, we are increasing the load. For safety, you will increase the load and you will decrease the strength. When you will be safe? When you increase the load and you decrease the strength. So, here the safety factor is introduced both on the load as well as the strength to take into account any possible overloading or understrength. Am I clear till here? Have you seen this? What is characteristic strength? Tell me fast. If you remember everything in RCC, just define characteristic strength for me. If you are able to define characteristic strength for me, then I will be clearly confident that you know what is limit state method, the basic philosophy behind the limit state method of design. Please define characteristic strength for me, please. You remember what is characteristic strength? So, characteristic strength is that strength below which not more than 5% of the samples will be following. So, strength below which not more than 5% of the sample will be following is known as the characteristic strength, and characteristic load is that load above which there will be occurrence of load only 5% times in the total design life of the structure. Means in the total design life of the structure, this load will be exceeded only with a probability of 5%. So, with the 5% probability of exceedance, the load is known as characteristic load, whereas characteristic strength is defined as the strength below which not more than 5% of the sample will be following. So, this characteristic value is related to 5%, but the definition for strength and load is different. Okay, for load, not more than 5% load will be exceeding the characteristic load, and characteristic strength means not more than 5% of the sample will be below the characteristic strength. Got my point? So, the characteristic values are the values that are not expected to be exceeded with more than 5% probability during the life or the design life of the structure. This gamma f and gamma m, you understand? See, there are two types of limit state now. One is the ultimate limit state and second was the limit state of serviceability. This all you have heard. If you had heard, please let me know, then I will skip this part, because this part is already covered in RCC as well. Have you heard there are two types of limit state? One is the limit state of strength or the ultimate limit state, and the second one is the limit state of serviceability. So, we design the structure based on the ultimate limit state or limit state of strength, and we check the structure for limit state of serviceability. If my structure is satisfying both the criteria, then we are safe, otherwise we are not safe. These are all the limit state of strength we will be analyzing. This same limit state of strength you have seen in RCC as well. First, we have to ensure that there is no loss of equilibrium of the structure or whole or any of its parts or components. There should not be any loss of stability of the structure. There should not be any excessive deformation or rupture. Rupture means fracture of the structure or any of its parts or components. and there should not be any brittle fracture. These are the basic limit state of strength. Okay, I am proceeding further. Then these are the basic limit state of serviceability, same that you have studied in RCC. Your deformation and deflection should be well within the permissible deflection limits under the serviceability loads. So, whenever you talk about the serviceability condition, you talk only on working loads. So, these serviceability checks are done on the basis of the working loads, whereas the ultimate loads or the ultimate limit state is checked on the basis of the factor loads. Okay. So, your deflections and deformation should be, which may adversely affect the appearance or effective use of the structure, or may cause improper functioning of equipments or services, or may cause damage to finishes or non-structure members. Vibration in the structure should not be there, or any of its components causing discomfort to the people, damages to the structure, etc. There should not be any corrosion or durability. Okay, your steel structure should be durable. There should not be any rusting. So, proper rusting treatment should be given to it. There should not be any water stagnant on the structure, because this water is enemy for steel structure, causing rusting in the steel structure, and then there should be fire resistance here. Okay. So, these are the basic limit state of serviceability that you have to satisfy while designing the steel structures. Okay, I am going further. See, the IS 800-2007 that we will be studying in this course in detail is largely based on limit state method of design, and I would be studying the limit state method of design only in detail. The structure is designed for ultimate limit state, as I told, and check for serviceability limit state. This is how the design is done. Not going into detail. These are the various partial safety factor for material. You have to remember this. If the resistance is governed by yielding criteria, the partial safety factor is gamma MO 1.1. If the factor, if the material is failing by buckling, then also gamma MO will be used 1.10. But if the structure is failing by rupture, that is a critical condition. So, the safety factor is increased. So, if the resistance is governed by ultimate stress, that is fracture, then we will be using 1.25. For yield stress, the partial safety factor is 1.10. For ultimate stress, the partial safety factor will be 1.25, because at ultimate stress your failure will be more critical. So, partial safety factor is increased there. Got my point? Then for various type of connections, these are the partial safety factor for bolted type, bolt, friction type and bearing type. What is friction type connection and what is bearing type connection? That I will cover in bolted connection only, don't worry. Partial safety factor is 1.25 only for bolts. But for welds, for shop fabrication, the partial safety factor is 1.25, but for field fabrication is 1.50. See, in the case of bolting, whether you construct, shop means industrial shop. Shop, you understand now? That is factory. Shop means here what? Factory. So, you can either have a section built in factory, or you can either have a section built at site. Shop, you understand now, my dear friends? You understand what is the meaning of shop? Shop means workshop here. Okay, that is a factory, that is known as shop. Obviously, whenever you are fabricating the sections in shop, the safety will be more. So, partial safety factor can be reduced. So, whenever you are welding in factory, the welding will be more controlled, more safer. But when you are welding in field, there the impurities in the weld will be more. So, the welding defects will increase. So, partial safety factor is therefore increased for welding. But for bolting, whether you do in field or at shop, it is not a matter of concern. Why? Because in the case of bolting, you have to just tighten the nut. You tightening the nut, if you are doing at shop or at field, it will make no difference. Therefore, partial safety factor for bolting and riveting is same, but for weld it is different. Please make a note of it. Okay. Now, partial safety factor for load, this is the same partial safety factor for loading that you have used in RCC. You remember this table? Please let me know, or do I have to discuss it in detail? This you have already discussed in RCC, so I don't want to do. The same table is there. We have various kind of load combinations. DL means dead load, LL means live load, CL means crane load, and WL means wind load, EL means earthquake loads. So we have various combinations of loads here. You will take various combination of loads, and out of which, for which combination you will design, out of this combination whichever yields the maximum load, that will be used in the design. Okay, so we will take various combination of load and we will apply the partial safety factor for loads as given here. For example, if you take the combination of dead load and live load, the partial safety factor is 1.5. If you take the combination of dead load, live load and wind load, the partial safety factor is 1.2, 1.2, 1.2. Why the partial safety factor is decreased? Because the wind load and earthquake load have less probability of occurrence. So since the probability of occurrence have decreased, so the partial safety factor is also decreasing. This you understand now? Shall I proceed further? So you will take all the combinations, and for which combination you will design? The worst of all, that is the combination which will yield us the maximum load. This table you have seen in RCC as well. Have you seen or not? Please let me know, then I will proceed further. Very simple table. Tell me fast, have you seen this table or not? Are you all there with me? You have already studied in RCC, so I am not going into detail here. These are all the loads I have mentioned. DL means dead load, live load, crane load, wind load, earthquake load, etc. This all you have understood. This factor of 0.9 also you understand. When you will take 0.9, when your dead load is giving us stability. In that case, the factor of safety you would use as 0.9. Okay. Please do this question now. Please attempt this question. Very simple question. Please attempt this question once, then I will proceed further. So out of this, which one is the ultimate limit state? Which of the following is considered as the ultimate limit state in limit state design? See, fire is the limit state of serviceability. Vibration is also the limit state of serviceability. Corrosion and durability is also the limit state of serviceability. Stability against overturning. This is my ultimate limit state. So correct answer is what, my dear friend? Correct answer is A. So your ultimate limit state is stability against overturning. Very good. Now if you understand the concept of load, I want you to attempt this question once. Okay. I have given you the partial safety factor for dead load and imposed load, dead load, wind load, all the load combination and their partial safety factor I have given to you. Okay. Just I have to on the slide map now, then only you would be able to attempt this question. Let me on the slide map here once. I forgot to on the timeline here. Once the timeline is there, it will become very simple for you. Let's see one simple question here. This is English batch. Here, English batch. I have put on the timeline. Now you can see the timeline. Try to attempt this question. I am giving you 2 minutes time. Please try to attempt this question. Very simple question. Just you have to take the worst combination of load and you have to find out the bending moment for the simply supported beam. So, maximum bending moment for a simply supported beam you already understand. It is WL square by 8 and maximum shear force is WL by 2. Let us see this question. Please try to attempt this question and tell me the answer. Here all the partial safety factor I am given to you. You can take a photo of this and then attempt the question. Okay. I am giving you 5 minutes time. Let us see if you are able to attempt this question or not. This you have done in RCC as well. When you are done, please let me know, Mr. Abdul and Mr. Uday Shankar. Are you solving it or not? Tell me fast. Very good, Abdul. You are attempting it. Very good, beta. Let's see. First, let us take, see, the dead load is given to me. This is dead load. And this is my imposed load, that is the live load also. Imposed load and live load is one and the same thing. And this is wind load, that is WL. Okay. These are all characteristic loads. So, first we will take the limit state of collapse and then we will take the limit state of serviceability. First, you will find out the worst UDL and then you have to calculate the design bending moment and design shear force for the most critical combination. First, let us talk about the limit state of collapse. Okay. First, I am talking about the limit state of collapse. Limit state of collapse, how do we calculate it? Very simple. First combination is dead load plus live load or imposed load, one and the same thing. You call it imposed load or live load, is one and the same thing. Or dead load plus IL, I will write. Dead load plus imposed load. If you take this combination, the partial safety factor is 1.5, 1.5. So 1.5 into 15, 1.5 into 10. How much you are getting here? Tell me fast. Please reply also. Make it fast, please. How much you are getting? You are getting it as 37.5 kilonewton per meter. Like this only you will do. Then next load combination you will take. We have then wind load also here. So dead load plus wind load. Here for the dead load, it is giving us stability. So here the partial safety factor that was given in the question was 0.9. These partial safety factors will be given in the question. Don't worry, you don't have to remember all these. Not required actually. In your gate, this will be given to you. Dead load plus wind load, that is 0.9 into 10 plus your wind load is how much? That is 5. How much you are getting here? That is 1.5 into 5. How much you are getting here? 21 kilonewton per meter. This is less, not critical. Now, dead load plus imposed load plus wind load. Safety factor is 1.2. 1.2 into 10. 1.2 into, this was 15, sorry, this was not 10, this is 15. By mistake I have written 10. 15, no? This is also 15. Dead load was 15, no? Yeah, now it's perfect. Plus 1.2 into 5. How much you will get here? Tell me fast. This is 36 kilonewton per meter. So out of this, which is the worst combination? This one. This is the most critical one. For this only you will design. So my design load is this, but we have to find out the design bending moment. This is the most critical combination, and for this UDL only you will design. So you will have to find the maximum bending moment here. For simply supported beam, calculate the design bending moment. So maximum bending moment for UDL is WL square by 8. You understand now? For simply supported beam, it was mentioned in the question, maximum bending moment is equal to W L square by 8. W is the load, that is 37.5. This you have not calculated, Mr. Abdul. We wanted, this span was given to me 6 meters. So we have to find out the maximum bending moment and shear force. Maximum shear force will be at the support, that is WL by 2. 6 square by 2. How much you are getting? Tell me fast. This is my final answer, 168.75 kilonewton meter. And maximum shear force is how much you are getting? Tell me fast. WL by 2, that is 37.5 into 6 divided by 2. How much you are getting? That is 112.5 kilonewton. This is the maximum bending moment and maximum shear force under limit state of collapse. Okay. Now the same thing I will repeat for limit state of serviceability. The same thing I will repeat. Few changes would be there. Here these load factors will change. Combinations will be same. Just the load factors will change. Okay. Load factors will change here. Otherwise, basic things are same only. Now, next part I am doing. Please attempt the next part. Tell me the answer what you are getting. क्लियर है? तो भाई इसका बस आप लिमिट स्टेट ऑफ सर्विसिबिलिटी का चेक लगाते हैं. you would have done a check for limit state of serviceability. Okay, Mr. Abdul. Now, when you check here, the same combination of load you are taking, but the partial safety factor will change. For dead load plus imposed load 1, 1, 1, 0.8, 0.8. So, this you will take 1, 1, 1, 1, 1, 0.8, 0.8. The values will also change here. In the first case, you will get 25, 20, 27. This only you are getting. So, the most critical one will shift now. This would be my most critical one now. Okay. This will become my most critical. This would be my most critical one now. In this case, this is the most critical combination. Here, this is giving me the maximum load. So, here I would be designing for 25. What is the value you are getting? Mr. Abdul, your answer is very correct, 121.5 and 81. You can expect this kind of question in your gate also. Okay. This is the kind of question that they generally asked for loading. You know what is the code to calculate the loads? This you have been taught in RCC as well. What is the code, IS code for calculation of loads? How do you calculate loads? The loads are calculated on the basis of an IS code. What is the IS code that is used for calculation of load? Tell me fast please. Which IS code is used? Obviously IS 875. There are 4 parts, part 1, 2, 3, 4. This is actually used for calculation of loads. Loads are of various types. Dead load, live load, environmental load. These are the various type of loads you have already studied in RCC, so I am not going into detail. I want to discuss here only one load. See, earthquake load also you have discussed there. Just a wind load I have to discuss. Environmental loads can be wind load, seismic load, snow and rain load. I want to discuss the wind load here, which is given in IS 875 part 3. Just I want to give a brief on the wind load. See, wind load is the wind force that is exerted on any structure due to the flow of the wind, due to the wind velocity. Okay. For low height structure it is not important, but for the structure which is large and which is having great height, there the wind load should be considered. So, here for the whole India is actually divided into 1, 2, 3, 4, 5, 6 zones, and on the basis of these 6 zones some basic wind speed is given. This is given in the code. This whole India map is given to us. So, the entire country is actually divided into 6 zones, and for every zone the wind speed is given to me for a 50 years return period. So, first you will have a basic wind speed that is adopted on the basis of the map given in the code. Now, from there I will calculate the design wind speed. This is the formula for design wind speed. See, design wind speed is equal to what? VB, that is the basic wind speed that you will get from the code. K1, K2, K3, K4 are 4 factors. K1 is the probability factor of the risk coefficient that will depend upon the design life of the structure. If the design life is 50 years, K1 will be 1, but if the design life is different, then 50 years, because VB is for 50-year return period. If your design life is different than the 50-year, then you will have to multiply it with the factor K1. K2 is the terrain, height and structure size factor. K3 is the topography factor where the structure is located, and K4 is the importance factor for cyclonic regions. These all factors will be given to you in exam, don't worry. In exam, whenever question will come, K1, K2, K3 factor will be given to you. You just have to calculate the design speed. See, code have given certain recommendations for calculation of these K1, K2, K3 factor that you can see here. Okay. K1, K2 factor like this you will calculate. Code in these recommendations are given in code, but you don't have to remember. In exam, if questions will come, K1, K2, K3, K4 factor will be given to you, don't worry. On the basis of that, you will calculate the design wind speed. Once the design wind speed is calculated, you will calculate the design wind pressure. How the design wind pressure is calculated, please see. Design wind pressure, how you will calculate it. See, wind pressure at any height Z First, you will calculate the wind pressure. Wind pressure is 0.6 into Vz square, where Vz is this is the empirical formula. Please remember this formula, very important. Many times objective questions are asked from this topic. So, design wind pressure you have to calculate. For that, you will have to calculate wind pressure first in Newton per meter square, that is in Pascal. This wind pressure will come out in Pascals here, okay, Newton per meter square. This will come out in Pascal, empirical formula, and here the wind speed you will put in meter per second. So, Vz is the design wind speed that I have already calculated at a height z in meter per second. Now, design wind pressure then can be obtained as follows. Design wind pressure will be calculated as Kd, Ka, Kc into Pz. Again, Kd, Ka, Kc are wind directionality factor, area averaging factor and combination factor. Again, these factors will be given to you in exam. Just you should know where to use it. Once you got the design wind pressure, you can calculate the design wind load just by multiplying it by area. See this Kd, K, Kc will be calculated like this. See, these you do not have to remember, everything will be given to you in exam, do not worry, because without code you can't calculate these factors. Then lastly, once you know the wind pressure, the wind load can be calculated like this. It is F is equal to Cf A into Pd. A is the effective frontal area over which the wind pressure is acting. Cf is the force coefficient, will be calculated from code, and F is the wind force, okay, in the direction specified. So, this is how the wind load is calculated. Got my point? Let us do some objective question on this part, then I will proceed further. Let us do few questions here, then I will proceed further. Are you ready for a question? Let me give you a question here. Please try to solve this question. Only one basic question I need you to solve it. Please solve it. Please try to solve this question. Let us see how much you understood. These kind of simple questions on the wind load you can expect in exam. Wind load was not taught to you in RCC, so that I have covered here. Okay. Was wind load covered in RCC? Tell me fast, my dear friends. Abdul, was wind load covered in RCC, my dear boy? Okay, you have solved it, my dear boy. The structure is to be constructed in a non-cyclonic region where basic wind speed was given to me. Vb is how much? 47 meter per second. Vz first you have to calculate, that is K1, K2, K3, K4, Vb. See, K1 risk factor is 1, size factor is 0.98, topographic factor is 1, non-cyclonic region, so factor is 1 again, into 47. So, for non-cyclonic region K1, K4 will be 1 only. So, this is 46.06. Now, the basic wind pressure, that is Pz, I need to calculate, that is 0.6 Vz square. 0.6 into 46.06 whole square. How much answer you will get? 1272. Nearest answer I will click. This is the answer you are getting. Nearest answer is B, my dear friend. Or not A, B was correct, my dear friend. B. 46.06, correct. Option B was correct, not A. B was correct, na? Option B. Okay, chalo, let's proceed further again. Now, these are the mechanical properties of steel that you will use. See here, these properties are very different as compared to that you are using in the RCC. There Fe 415 means yield stress is 415, but here if examiner gives you Fe 410, it means ultimate stress is 410. See, the reinforcing steel and structural steel is different, so please don't mix it. Here Fe 410 grade means Fy is 250 MPa, this is the yield strength, and your ultimate strength is 410 MPa. Your yield strength will depend upon the thickness of the material also, but if nothing is mentioned, you will always consider yield strength to be 250 MPa. For Fe 410, here different grades of steels are used, A, B, C, based on their fatigue failure tendency. Okay, I am not going into detail, not required. For Fe 440, the yield strength is 330 and the ultimate strength is 440, and these are the various grades of steel that are generally used in design of steel structures. E250 signifies the yield strength and 410 signifies the ultimate strength of steel. Okay. Moreover, these are the basic mechanical properties that we will use. Modulus of elasticity here in the steel 2 gigapascal, that is 200 MPa. Sorry, 200 GPa, that is 2 into 10 to the power 5 MPa. Shear modulus is 0.8 into 10 to the power 5 MPa. Poisson ratio is 0.3 for elastic range and for 0.5 for plastic range. Coefficient of thermal expansion will be taken as 12 into 10 to the power 5 per degree Celsius. Okay. So, these are the basic mechanical properties that we would be using in design of steel structures. Okay. Poisson ratio of the steel in the elastic range. Earlier code said it to be 0.25, but in the new code it is written 0.3. So, please remember this. Correct answer will be 0.3 here. I am proceeding further. This is a convention for member axis in the case of I section. This is taken as my Z axis. This is my Z axis, that is perpendicular to the web, and the axis perpendicular to the flanges is Y axis, and the longitudinal axis is what? It is taken as the longitudinal axis is actually my X axis, that is along the length of the member. For angle section, this UU and VV are the major and minor principal axis. This is the major principal axis is UU and VV is the minor principal axis, this you understand, and ZZ is the axis perpendicular to the one leg and YY is the axis perpendicular to the another leg. This is the convention for member axis that I will adopt throughout the steel structure. So, for I section, ZZ axis is perpendicular to the web, YY axis is perpendicular to flanges. These are the major and minor principal axis here. ZZ is the major axis and YY is the minor principal axis. For angle section, UU is the major principal axis and VV is the minor principal axis that you have already studied in strength of material also. So, this was all about the general design consideration. So, we have seen the loads here. I have introduced the topic. Now in the next class, that is after half an hour, you will see to it, we will be starting with plastic analysis. Am I clear till here? We have seen design philosophies here. And lastly, I have talked about loads, very simple. Now I will be discussing plastic analysis, but after a short break. So please join after at 7:30 your next class will begin. I guess the time is 7:30 only. What is the time of the next class? Please tell me. Abdul, are you finding the notification? Okay, your next class is at 6:30, I guess. Next class is at 6:30. It's already 6:30. At 7:15 we will start the next class. At 7:15 let us start the next class. I will reschedule. Okay, 7:30 only it is rescheduled. So at 7:30 I will begin the next class. Let's take a short break. We will meet at 7:30 p.m. again. There I will start with plastic analysis. So let's take a break.